applications engineers, you're going to love this video. I'm at the Engineering Technology Group. Don't forget to like, comment and subscribe if you enjoy what you see. I'm with Steve Brown. We're going to be looking at an application you would normally consider to be done on a milling machine, but actually it's being done here on the Nakamura SC-300. This isn't just about the machine, is it? I know we can wax lyrical and talk about how good this piece of kit is, which I'm sure everybody knows. Japanese-built Nakamura machines. I would say they keep bringing out new technologies as well, but we will come on to that. This is about the story of what ETG have done for a customer to provide a solution that you wouldn't normally consider. Would that be right? And can you tell us what it is?
Yeah, so completely right. So this is an applications product that we wanted to put forward. So naturally, we all sing about twin spindles, single turrets and everything, but I don't think even in your portfolio, you will have another video expressing what we're going to show you, what we're showing you today. Basically, it's extruded material.
All right, walk us through it then. What is it? What are you doing? What have you done?
Right, so on this particular application, if you imagine an extruded component, or profiled component, so the two different terms that people use. So we've taken that component, we've offered it up into a bespoke bar feed supplied by Hydrofeed. So obviously we have a nature of different profile components. So if we pick this up, for example, that's the initial work holding that we've got there, and you can see this is the nature and the profile of the component itself, which we're going to bar feed through. Okay.
So to start in with the bar feed, they would normally have liners to support the bar, I believe. What's different in there then?
So basically we're loading through a rectangle and odd portfolio of shape, you know. So yeah, you're exactly right. You'd have a set of rollers that goes into a bushing system, then we'd load through bushes that are within the spindle housing itself. They've configured the bar feed so it has a conveyor system that we've got two grippers that pulls the bar material through. Then the push rod comes all the way through, and this support system here goes through the entire spindle. Then when we change over to a different profile of material, we change the work holding collet, and we change the through bore work holding.
Okay, so the trick to this is it's a part that may have been done, or a quantity of parts that would have been done maybe using a milling machine, a vertical machining center, or some form of prismatic machine type, but now you've flipped that completely and it's being done on a multi-axis turning center.
Yeah.
How?
Exactly. So this we can't show you the part because obviously it's very, very sensitive, but it's an aerospace part, okay? And it's a family of parts. So if we just take that profile as an example, historically that would have been done on a milling machine. So we'd have had a 3 meter length of material. The customer would have chopped those up all into the relevant pieces. We'd have manually loaded these into a VMC, and we'd have drilled, tapped, and milled off the front faces. Okay, so they're probably talking about 5 or 6 machines going through. To automate, yes, we can come in with a robot and load in and out of the machine and so forth. We looked at the whole cell, and we're putting the same capacity through this one machine. Change over time, you're probably talking 2 minutes to change over from one liner and the collet. So the flexibility that we've given them in one machine is going to take out another 5 cell arrangement.
Okay, but critical to this is there's no real turning, is there? It's all milling.
Correct. Yeah. The only turning element that we're doing is the spindle will be slowly rotating when we come to part off. So again, if you can picture a profiled component, we could have it 20 millimeters long for a small batch, which we can handle. We catch through the parts catcher, or we could have it as a 1200 mil section, because we take that profile all the way through to the sub spindle. Because for those longer parts, we keep double feeding. We use the sub spindle with the same configuration of work holding to support while we're dragging the component through.
So I'm kind of thinking here about maybe an aero structure or something like that that I've seen even on your Chiron machines, being machined between centers. There's the capability here to be able to use these two spindles, both to support really, and then the power of your turret here to actually do the milling. I mean, are we saying then that this milling is more than capable of handling all types of machining?
Yeah, we've done with the AS product that we have, we've put 6 of those machines into a milling environment where the spindle is literally acting as a fourth axis, you know. So the arrangement that we've got on this machine is they're aluminium extruded parts. Okay, so we need that that high RPM. We do have a steel configuration that's going through the cell as well, which means we need necessarily lower RPM but more torque.
And you can do that too.
Yeah, particularly in this machine, that's what we've got the advantages of both. Yes, we won't have the 20,000 RPM spindle that we have like on the Chiron or a dedicated five axis, but we've got the flexibility in this cell. So you can almost say what we're getting out of this cell compared to that milling environment, and waiting for the hold up from the parts coming off the saw. And then you got whip, haven't you? The parts are sitting there waiting to get to the machine. We have one job on this machine, and that's basically keep feeding that bar feed.
What's the value to the customer? You talk about it replacing a different cell. Is there a quantifiable, 60% better output, 30% better, or savings of X, Y, or Z? What could you actually say to put it down to?
Well, footprint is key, isn't it? So these businesses currently are winning more and more orders. So if you can picture 5 milling machines in an area of a factory, and we're going to replace it by this cell here, one has got more expansion for investment in other projects. So you would obviously have overheads against that particular project. We've just got rid of all of those. It has enabled him to re-quote the project and get it on a better price, increasing his margins because he's got a dedicated machine that will now be running also out of hours.
Power consumption from 5 machines compared to 1?
Exactly, yeah. So electric isn't cheap nowadays, is it? So there's lots of factors that basically, when we just put the basics of the proposal back to the customer, you could see the penny starting to drop.
How important is it for other manufacturers watching this video and others that we shoot to actually try and reconsider how they're making their parts, because there could be a more efficient way? And if they do think like that, how do they get hold of you, Steve? Or maybe not you, because it's probably your apps guys, is it?
Yeah, it'll be our technical department, but it's a real game changer. Anything that you're machining, you should really approach us. If you're looking to take cost out of the part, you should really approach us and just let us look at the part itself and let us give you our proposal and our offerings. From what we have within our portfolio, whether it be Nakamura, Quasar or Chiron, we have the 50 gram machine, we have a £5 million machine. So the concept, we will have something that would help you as a customer.